Next, next let's look at hypothesis testing for the difference in the population means mu sub 1 minus mu sub 2. We've already seen the three types of hypotheses that are possible, the two-tailed test and the two one-tailed test, with d sub 0 representing the value in the hypothesis for the difference in the population means. Now let's look at an example from the textbook. Here we have, as part of the study, we are looking at two training centers, and we want to see whether there is a difference in the average examination scores of individuals trained in these two different training centers. So the mean examination scores is what we are interested in. So mu sub 1 is mean examination score for population of individuals trained at the training center A, and training center B is the second one. So let's first define all of these terminologies. So we have population 1 and population 2, which are examination scores from training center A and training center B. And then we have mu sub 1 and mu sub 2. Mu sub 1 is the mean examination scores for all the individuals trained in center A, and then center B will be mu sub 2. So we have defined mu sub 1 and mu sub 2. Now we want to test whether there is a difference. So our hypothesis should be, our alternative hypothesis is the difference, whether it is not equal to mu sub 1. So you go to insert symbol and you can select the symbol you want. So we want not equal to 0. So d sub 0 here is 0, and this will be equal to mu sub 1 minus mu sub 2 equal to 0, which means there is no difference. Not equal to 0 means there is a difference. Now let's gather the information given in the problem. So here we are told that sigma sub 1 is 10 and sigma sub 2 is also 10, and alpha is 0.05 level of significance. So sigma sub 1 is 10, that is 10, and 5% is the alpha value. And the sample information are also given. N sub 1 is 30, N sub 2 is 40, and the means are 82 and 78 for the scores. So 30 and 40, 82 and 78. Okay, now point estimate for the difference is the x bar sub 1 minus x bar sub 2. The standard error of estimate, since sigma 1 and sigma 2 are known, it is square root of, you square the standard deviation and divide by the sample size for the first sample and the second. So this will give us the standard error of the estimate. Now d sub 0 is the right hand side value for the hypothesis. So we can select one of them. They both must be same, obviously. And then we compute the calculated value for z, which we using the formula. It is point estimate minus d sub 0 divided by the standard error. That will give us the calculated statistic, z statistics, calculated z value. Then we can do the test either by using this, comparing the z calc with the z table value, or we can compute the p value. So let's first do the test using z table value. Now, z table value, you need to look at the type of hypothesis, which is alternative hypothesis, which is not equal to. So we need to go norm.s.inv. Now we want the positive side. So we do 1 minus alpha over 2. Okay. So this will give us the z statistic, and if z calc is greater than the z table value, the absolute value of z calc. So here, since the absolute value of z calc it is not, so it is less than z table value, so we say do not reject H sub O. Now we need to go on make the subscripts and so on. So let's do that now. Okay, so we cannot reject because of this. Now we can do the same thing, same test using the p-value. The p-value is found by first, we do it step by step, norm.s.dist, and if we select the z calc value, z calc is here. Okay, so this will give us the cumulative probability. So the z value comma 1 for cumulative probability, and this will give us the cumulative probability. If this was a negative z value, that would be the tail area. But since this is a positive value, the tail area is on the opposite side, so we need to do 1 minus that for the tail area. So depending upon the value of z, you need to be careful how you find the tail area. Since this is a two-tailed test, we have to take the tail area and multiply by the number of tails, and that will give us the p-value. So the p-value, okay, let's make that into a percentage. So now, since the p-value is larger than alpha, we cannot reject, because if we reject, the probability of type 1 error is too large, 9.8%. So we cannot reject the null hypothesis. So let's write the conclusion. Okay, since p-value is greater than alpha, do not reject H sub O. So now we need to interpret the conclusion. So the first part of the interpretation is we do not have sufficient evidence to conclude the mean examination scores for the two different training centers are different. Now we have to put a caveat for this to see what we need to interpret the p-value also. So if we did reject the null hypothesis, then the probability of committing type 1 error will be 9.8%. So we have to add that here. Okay. And the probability that we'll be wrong is 9.8%. So let's now to justify. Okay. So that will justify the text for us.